Access modifiers could be classified, I guess you could say, as partners in crime with classes when it comes to encapsulation, because classes themselves and the members within them can be assigned different accessibility levels, meaning you can determine the visibility of the functionality to other code. Now keep in mind, if we build a class and if we build certain classes in an application and then turn that into a DLL, we compile that as a DLL and make that DLL available out there, other programmers can set a reference to that DLL and then access that DLL and create objects off those classes. But of course, they're only going to be able to see code for different accessibility levels that we give them. So think about this. You've seen it already in the course. We write a method, public void do this. Well, this do this method, since it has the public keyword, means that from outside this class or an object instantiated from this class, you can call this do this method. Now, if you marked it as private void do this, or if you left private off because it defaults to private in C#, this do this method would not be visible from outside the object or the class, and so therefore you would never know that this is running. Now this may have 300-400 lines of code in it, it's connecting to databases, it's verifying all sorts of things, but you wouldn't be able to see this. And so access modifiers help. Now there are 5 access modifiers in C# that we can use to determine the visibility of the various methods, properties, and so forth in relation to other code. There's public, private, protected, internal, and protected internal. So let's talk about each one of these. Now, if you use the public access modifier, that means the type or member can be accessed by any other code in the same assembly or any other assembly that references. Keep in mind, in this context, an assembly is basically a compiled project that's compiled to like an executable file, a .exe, or a DLL file, etc. Now the private modifier means that that particular type or member that's marked as private can be accessed only by code within that same class or struct. We haven't talked about structs yet. We'll talk about those later. But for now, just understand, when we put that private keyword on something, it means people from outside can't see this one. And it can only be called from code inside that particular class or an object instantiated from that class. Then the protected modifier means that the type or member can be accessed only by code in the same class or struct or in a class that is derived from that class. Now, go back to the inheritance videos. When we talked about inheritance, a derived class is a class that's inheriting from a parent class. Now, internal, when you use that modifier, it means the type or member can be accessed by any code in the same assembly, but not from another assembly. And then protected internal means that the type or member can be accessed by any code in the assembly in which it's declared or from within a derived class in another assembly. In other words, if we're inheriting from a class in this assembly, we can use in a derived class in another assembly, and access from that other assembly must take place within a class declaration that derives from the class in which the protected internal element is declared. Now, it also must take place through an instance of that derived class type. If all that makes sense, good. If it don't worry about it right now. At some point, you may run into a situation where you need different kinds of access, and you can come back and check these and see what you need to do. However, going into the exam, make sure you understand how these are going to affect your ability to see the various members in a class, or even the class itself. If the class is modified with these, how it's going to behave in the application as well. So just be familiar with these, watch for these on the exam, and don't let them trip you up on any questions when it comes to access modifiers on your types or members.